Welcome friends. Today we are going to see the most important part when we are talking about ASME Section 8 Division 2. So there are two most important documents when we are talking about ASME Section 8 Division 2 are called as UDS and MDER. UDS stands for the user's design specifications, where all the inputs for the designer must be given by the user or its designated agent, and MDER, which is also called as manufacturer's design report. So the manufacturer or the designer should prepare one report which giving you all the information about the drawing, then design calculations, all the assumptions, everything will be considered under that MDER. So let us start with the first document, which is called as user design specification. If we compare this with ASME section at division 1, there is a document called as UDR in division 1, which is called as the user design requirement. Similar to that, in division 2, it is called as UDS, that is user design specification. So mostly all the data is similar to what we have seen in division 1 UDR. Here, what are the things which needs to be covered under UDS? So as the name suggests, these are the specifications prepared by the user or his designated agent, which are necessary for the correctly designing and manufacturing the pressure vessel. So whatever information needs to be provided to the designer for its correct designing and manufacturing is called as UDS. And whose responsibility is this? This is the responsibility of the end user or his designated agent. Now, in terms of code language, if you would like to review it one more time, in code language, the definition is the user's design specification shall contain sufficient detail to provide a complete basis for design and construction in accordance with this division. Which division? Section 8 division 2. So here what has been written? The user design specification shall contain sufficient detail to provide a complete basis for design and for the construction in accordance with this division. It is whose responsibility? The user's responsibility to specify or cost to be specified the effective code addition. What are the things that needs to be put inside that UDS? The effective code addition and the vessel class to be used for the construction. So the class of the vessel, whether it is class 1 or class 2, or which addition of the code to be followed, that needs to be provided by the user or his designated agent in the UDS. So what are the things which are primarily covered under this UDS? The UDS is a very critical document which shall be mandatorily be available before commencement of the design activities for the pressure vessel designed as per section 8 division 2. So the UDS is a very important document, and that needs to be made available before starting the design, because all the inputs must be given in the UDS. So without UDS, you should not start the design. So let us see in the code how it has been given. So what are the UDS requirements? What are the different things that needs to be specified by the user in the UDS? So let us open the code. So if we go to the part 2, responsibilities and duties, if we get into the part 2 for the responsibility and duties, in that 2.2.3, the clause number 2.2.3 will tell us about the requirements of users design specifications. So if you would like to get into the details, you have to refer to which clause? 2.2.3, which is for users design specification. So what are the things which are mentioned over here? The user design specification shall include but not necessarily be limited to the following. Means what? The following information should be given, but apart from this information, what has been mentioned in the code, if there are some other loadings or applications are required, then those also needs to be mentioned under UDS. So the following things are necessarily to be mentioned. So what are those things? Let us see the green highlighted one, which are nothing but the head points. So installation site. So where this equipment will be installed, that installation site information to be provided. Then vessel identification. When we are talking about the vessel, what is its tag number, manufacturer serial number, how you are going to identify that vessel. So that vessel identification is very important. Then vessel configuration and controlling dimensions. So what are the outline drawings? If the customer is having some process design done, so accordingly that they have designed the volume, diameter, pressure, nozzle sizes, openings, the type of supports, all these things should come under this clause vessel configuration and controlling dimensions. Then comes the design conditions. For which conditions the vessel to be designed for? All those important things like design pressure, design temperature, the applicable loads, all these things needs to be defined under design conditions. Then comes the next one, which is operating conditions. So what are the actual operating conditions for that pressure vessel? What are the operating pressure, operating temperatures? What are the live load, dead loads during the operation? Those things needs to be provided under operating conditions. If the vessel is under any cyclic service or if there is any fatigue life assessment to be done, so all that information also needs to be provided under design fatigue life. So how many number of cycles are there? Are there any pressure cycle, temperature cycles, or it is a combination of pressure and temperature cycles? So all these information, are there any corrosion fatigue assessments are to be required? So all those things have to be specified under UDS, under the clause F, which tells us about the design fatigue life. Then the material of construction. Whenever we are talking about the pressure vessel, then it consists of multiple components like the shell, dish stand, nozzle, flanges, tubes, pipes, then supports. So what are the different materials that needs to be chosen for that? So all that information needs to be specified under material of construction. Then comes the loads and load cases. So in division 2, there is a load combination, combined load combinations has been given. So whether all those are applicable or there are any other kinds of loads that needs to be considered, wind load, seismic load, snow loading, internal pressure, external pressure, piping loads, fatigue life. So all those things needs to be mentioned under this clause H. Then comes the overpressure protection. So when we are talking about pressure vessels, specifically division 2, mostly it is used for 3000 psi and more pressure. Now it is alternative code, so we can use it from 15 psi onwards as well. So for the overpressure protection, there are requirements given under part 9. So all those requirements needs to be very clearly mentioned in your UDS. Then comes additional requirements. Apart from whatever we have seen, those are called as a mandatory or compulsory requirements. But apart from that, if the user or its designated agent wants some additional things to be done, so all those things needs to be specified as additional requirement. Like what kind of additional NDE is required, if there is any impact testing compulsorily to be done, what are the other things to be mentioned in the marking when you are going to have that marking on the vessel or on the nameplate. So all these additional requirements needs to be specified under this additional requirement clause. So this is what the clause 2.2.3 which guides us about the requirements of UDS, that is user design specification. So we are going to see one UDS for one demo job. So what are the things, how that has been written, what are the information that has been mentioned over there? Those all are the things what we are going to see over there. So let us say I am opening the UDS. So let's say this is the UDS document, what we have been talking about. So what are the important things? We have seen point by point what is given in 2.2.3. So whether all those things have been considered in actual UDS or not. User design specification and tag number, tag name, document number needs to be provided. Then obviously prepared by, checked by, approved by. Certification of compliance, the user's design specification. Here, whoever would be the this document would be certified by the design engineer or by the certifying engineer, or it can be a combination of both. Some part may be certified by the design engineer, some part if FEA is required, if fatigue assessment is required, then certifying engineer will come into the picture and its seal will also needs to be specified over here. Then comes the table of contents. So we have seen in detail what are the things that needs to be specified. First, let's say the introduction. This is a generic one that is been mentioned in that UDS. So the compulsory things have been given. In addition to that, you can add whatever is important from the user's perspective. So let's say the introduction from the user side. What is the purpose of that vessel? Definition, reference standards. Those can be considered. Then installation side. Then if we have seen the code requirement, right? In the code requirement, we have seen the installation site. Under that location, then jurisdictional authority, if applicable, the same things what has been given over here. So location, then jurisdictional authority, national board designation, registration, environmental conditions. Then we have seen vessel identification, vessel number, then service fluid properties, etc. Then comes the next one, which is the vessel configuration and controlling dimensions, its size, shape, whether it is vertical, horizontal, what are the overall diameter, height, tan line, dimensions. All those things comes under point number 4, vessel configuration and controlling dimensions. Then comes the design condition. What is the design pressure, design temperature, the loads under which the vessel needs to be designed for design condition. Then operating conditions. During the operation, what would be the pressure, temperature, if there is any thermal analysis to be done, what is the actual thermal gradient, fatigue life assessment, then design fatigue life. So there is a separate section given for design fatigue life, what we have seen in the code as well. So whether there is a requirement of fatigue assessment, if yes, then the requirements to be specified, how many number of cycles, whether there are pressure cycle, temperature cycles, combination, etc. Then material of construction. So what are the different material of construction to be used for the variety of the components, like for shell, distance, nozzle, supports, flanges, etc. Then load and load cases. So applicable load cases as per table 4.1.1, which is given in the code, the load combination. So whether all the load combinations are there, that needs to be specified. Then designing loading combination as per the table 4.1.2, calculation methods, all those things needs to be mentioned under load and load cases. Then comes the overpressure protection. The scope, as we have seen, as per the part 9, we have to see that. Then, if there are any additional requirements, those needs to be specified. And then comes the schematic arrangement. Whatever the drawing overall you need to follow, if the customer have prepared one, so that also needs to be attached. So this is in general how the UDS would look like. So you can see in the introduction, the purpose, why this vessel is there, what is the tag number, definitions, whether what do you mean by user, company, contractor, supplier, code, inspector, all these general information will be indicated over here under definition. Then what are the reference standards to be followed? B16.5, which edition? ASME B16.9, B16.10, B16.20 for the gaskets. So ASME section 2 part A for the ferrous and non-ferrous material, then section 2 part D for the material properties, etc. All the reference standards could be mentioned over here under the first part, which is called as an introduction, and in that reference standard. Then if you can just scroll down, then installation site. All the information which will be from design and manufacturing point of view important as far as the location of that particular pressure vessel is concerned. So here we can see where the location is. Let's say in this case we have considered Pune only. Then jurisdictional authority, national board registration. If it is US based, Canada based, then mostly NBR registration will be required. NB registration, what we can call it as. Here it is not, so it is not required. Environmental conditions. If there are any wind design loads to be followed, here IS 875. Then for seismic IS 1893. Then if there are any wind velocity, other factors to be specified, all can be given over here. Then snow loads if applicable. So unfortunately in Pune there is no snowfall, right? So this load case is not applicable. So lowest one day mean metal temperature that needs to be designed. Then vessel identification, tag number. Then service fluid properties like its density, its name. Then the liquid level, if at all it is to be mentioned. Then vessel configuration, whether it is a vertical vessel, a horizontal vessel. What are the different nozzles? What are the classes and sizes of those? What is the description of those nozzles? All these things. Then principal dimensions like the what is the inside diameter, tan to tan length, if there is any distance, whether which type of distance it is. Here you can see it is 2:1 semi-ellipsoidal dish end. Then the internal volume, if at all it is to be mentioned. Then supporting method, whether it is mounted on the skirt or the saddle support. Then design condition, the specified design condition, design pressure, design temperature. whether there is an external pressure applicable, design temperature, you can see it over here. Minimum design metal temperature, MT. In this case, it is 10 degrees Celsius, what has been mentioned. Then, is there any dead or live load to be considered? Nozzle loadings, if they are applicable. Then static loads, like what is the fabricated weight, empty weight, operating weight, hydro test weight, etc. If at all it is being given by the customer, then we can specify it. Otherwise, the in UDS it can be mentioned as by vendor. Once the design has been done, then these things can be confirmed, right? Because right now the design has not been done, so we are not aware about what is the weight, empty, operating, hydro test, fabricated weight. So the user also does not have this total information. So this is the document which has been prepared by whom? The user. So at that point of time, this information will be specified as by the vendor. Then the operating conditions. What is the operating pressure, temperature? Then fatigue life, what we have talked about, right? If there is any requirement of fatigue, then what are the number of cycles? Then those cycles needs to be specified over here, etc. All these informations you can see it from here, whether it is required or not. Then comes material of construction. For the various components, what is the MOC, material of construction, that needs to be followed? That can also seen from here. Is there any corrosion and erosion? If yes, then what is the value to be considered during the design? If it is stainless steel vessel, it is not required. Are there any special service requirement, lethal service, hydrogen sulfide service, HSS, what we can call it as? Then various load cases, loads and load cases. Here you can see these are the design load parameter. P is for internal and external pressure, P is for the static head, D is for the dead weight, L is for what? The apprentices load, E is for the earthquake, W for the wind load, S is for the snow load, F for the loads due to the deflagration. If there is any flame to be propagated because of that, if there is any load, that is called as the loads due to deflagration. So all those loads have been defined over here, and whether those are applicable or not, that has been mentioned by the user based upon its requirement and the site location and the process, whether these are required or not. Then comes the load combinations as per table 4.1.2 of ASME section and division 2. So what are the different load combinations? Here 8 load combinations have been specified. But if there are any other load specifications or requirements apart from the code, those also the user can specify under this table. Then comes additional requirement. If there is any NDE, non-destructive examination, or impact testing requirements are to be specified compulsorily. For specific requirements, some hydrogen crack corrosion, or let's say IGC test are to be specified. Those can be specified under this additional requirement. And then comes the schematic diagram. If it is available, then the customer can provide that as well. So with this important information, the user will specify all the requirement data, and on the basis of this data, the manufacturer and the design engineer will design all the equipment and manufacture the equipment, and then will prepare the MDER, which is called as the manufacturer's design report. So we have seen so far the requirements of UDS, how it has been given in the code and how it has been specified in the actual example. Then what do you mean by manufacturer's design report, MDER? Many times MDR also referred it as, but there are two MDRs. One is manufacturer's data report. So that's the reason why usually it is being termed as MDER, manufacturer's design report. So what do you mean by this MDER document? The manufacturer's design report is a combination of the final design documents like the as-built drawing, final calculation report. If there is an AFE report, then that also to be included over here. And whatever assumptions, if at all, are there, those needs to be specified under this manufacturer's design report. So after that, this report is prepared after the successful completion of hydro or pneumatic testing of the pressure vessel. When it is to be done, because here we also need to have what? The as-built drawing. As-built drawing means after hydro or pneumatic test, everything has been finalized, it has been approved, and now we can see what are the final dimensions. So that's the reason why this report is to be prepared after the successful completion of hydro or pneumatic testing of the pressure vessel. After completion of this report, the report will be along with the certificate of compliance is stamped by certifying engineer if applicable. If there is any FEA requirement, if there is any fatigue requirement where the requirement of certifying engineer will come into the picture, then that certifying engineer is going to certify it. Otherwise, the design engineer will put signature on the same, and the same will be approved by the authorized inspector. The MDER stamping by the certifying engineer, MDER stamping by certifying engineer is not mandatory for class 1 and for class 2 vessel unless there is a requirement of jurisdictional authority, FEA or fatigue assessment requirement. And if there is a QAC, quick actuating closure, and the other things what we have already seen under the roles and responsibilities. So when it comes to the manufacturer's design report, so what are the things which needs to be specified under that? So let us see that part as well. So for manufacturer's design report, we have to look into the clause 2.3.3. So as per ASME section 8 division 2, if we are referring to 2.3.3, the part 2 document, the manufacturer's design report. In this certification of the manufacturer's design report, who is supposed to certify that? That information is been given here. Whether the design will be certified by an engineer or by the certifying engineer. The certifying engineer will certify if it is having fatigue analysis to be done. If there are no equations given in part 4, for that we have performed part 5 analysis. If the vessel alternatively totally designed with the help of FEA, use of 4.8 for the designing of quick actuating closure, and if there is any dynamic seismic analysis. Under these circumstances, certifying engineer is going to certify that document. In all the other cases, the design report may be certified by the engineer or the designer, what has been specified in the code. So who will be called as engineer, designer and certifying engineer? For that, there is a separate lecture what has been prepared. So you can refer to the same. Now let us come to what are the different things which needs to be specified or considered in the manufacturer's design report. So the manufacturer shall provide the manufacturer's design report that includes the following. So what are the things? Final as-built drawings. So whatever the final as-built drawings are there, those needs to be specified under that. Those needs to be a part of this document. The actual material specification used for each component. So the material must be used for each component. For that, the actual material specification requirements needs to be specified. Then design calculations and analysis that establishes that the design as shown on the drawing complies with the requirements of this division for the design conditions which have been specified in UDS by the user. So all the design calculations as per part 4 or as per part 5, if there is any FEA required. The documentation of the design by rule calculations of part 5 or part 4 rather we can say, the documentation design by rule comes under part 4 shall be included. Under that, what is the name and version of the software that has been followed, if at all it is there. Then loading conditions, material model utilized, detailed calculations, summary of the calculation results. Everything should be specified under MDER, the documents, if designed by rule as per part 4. If as per part 5, then if there is any FEA required which is not given or the rules are not given as per part 4, for that if there is any part 5 or FEA requirements is there, if there is any fatigue analysis is required, all those reports needs to be specified under this, the part 5, right? The documentation design by analysis part. Under that, what are the things? A detailed description of the numerical method, then description of the model geometry, then what are the different elements during FEA has been used, whether those are the 2D, 3D elements has been used, then loading conditions and boundary conditions, then material properties like modulus of elasticity, Poisson's ratio, thermal expansion coefficient, thermal conductivity, thermal diffusivity, strength parameters like yield strength, then tensile strength, strain limits, all these things needs to be specified in that particular document. Then descriptions of whether the material nonlinearity has been considered, Then what type of analysis has been done, whether it is a static analysis, thermal analysis, buckling analysis, then graphical display of the relevant results. If it is to be done from the ANSYS, then various ANSYS display, or we can say the screenshots needs to be provided. Then the mesh sensitivity check also needs to be provided. Equilibrium check also needs to be a part of that particular report. Then linearization method, what has been used, use of the centroidal or nodal values. Then summary of the numerical analysis. All these things are related to the FEA. So if design by analysis is there, then all these things needs to be mentioned as a part of that particular report. And then comes any method of the design used that are not covered by the rules of this division. Let's say there is some geometry which is not covered under this. So if such case is there, those things also needs to be specified by which method you have done that. The results of any fatigue analysis according to 5.5 as applicable, those should be made available. Any assumptions used by the manufacturer to perform the vessel design. If there are any assumptions that has been followed, all those things needs to be specified in this manufacturer's design report. So let me just open this document, manufacturer's design report. This is the first page of this. So here the index will be provided. In this index, you can see what are the different documents which have been included. So first, let's say the design calculation, design by rules as per part 4, whether it is applicable, yes. The cross tells us whether it is applicable. So it is yes. So this has been made a part of this report. Then is there any part 5 analysis has been done? If yes, then you can mention it like the cross over here. In this case, it is not. So you can see over here, no. Then as built drawings, which includes the general arrangement, fabrication detail, nameplate, internal detail, transportation, etc. So all those have to be a part of this report. So here you can see it is yes. If there is any fatigue analysis, then you can mention it over here. In this case, it is no. Then actual material specification used for each component, those needs to be a part of this. And is there any assumptions additionally what you have considered during this design? So in this case, there are no such assumptions. So as we can see it over here, it is a combination of as-built drawing, then part 4 analysis. If there is part 5 analysis, all those things needs to be mentioned over here. Revision and the date also needs to be specified. So this is how the manufacturer's design report needs to be prepared and to be presented to the authorized inspector. And it can or cannot be reviewed by the certifying engineer, depends upon whether there is any FE or fatigue requirement, QAC requirements are there or not. So as per this, we have seen the most important documents. First one was the user design specification, according to which all the inputs needs to be provided to the manufacturer or the designer by the user or his designated agent. And with the help of that UDS, the designer should prepare the design calculation, and finally MDER by the manufacturers needs to be prepared and to be presented, which include the design calculation report, fatigue report, then as-built drawing, as well as if there is any material actual specifications, those also need to be made a part of this particular document. So I hope you must have enjoyed this lecture and understand or understood rather the requirements of UDS and MDER in detail.